Hello everyone, here I am going to discussing about the polarization state of the medium in terms of matrix representation that is given by John. That's why we call it John calculus. He written in terms of vectors and matrices. That is matrix treatment of the polarization. Consider the light ray. That is an instantaneous electric field vector as shown in the figure. That is the electric field vector along Ex, x-axis is Ex and the y-axis is Ey. Then Ex we can define in terms of plane wave equation E naught x e power I kz minus omega t plus pi x and Ey is equal to E naught y e power I kz minus omega t plus pi y. And pi x and pi y are the phases along x and y axis respectively. Next, combining these two components, we can written as E of kt is equal to x cap E naught x e power I kz minus omega t plus pi x plus y cap E naught y e power I kz minus omega t plus pi y. Then common I am taken for e power I kz minus omega t. Only x cap e naught x e power I pi x plus y cap e naught y e power I pi x. This is the e naught and e power I kz minus omega t. In this square bracket is a complex amplitude of the plane wave. For Jones vectors, the relative amplitudes E naught x and E naught y and the relative phases del is equal to pi y minus pi x in these phase components, and the complex amplitudes can be written as in terms of a matrix. That is a Jones vector I am written as E naught x E naught y matrix. That is E naught x e power I pi x e power I pi y E naught y. E naught I power e power I pi x I am taken the common or outside this matrix, then I am written as E naught x E naught y e power I del, where del is a pi y minus pi x. Here plus I pi x common tegure ikkade there is a e power I pi. That is the difference between these two phases, that is pi y minus pi x at where del has. Then next time we go to the how this Jones vector or Jones matrix represents for different polarizations. That is a linearly polarized, circularly polarized, and elliptically polarized light. First, I am going to the linearly polarized light for horizontally. That is an electric field oscillations are along the x-axis. The Jones vector can be written as for this horizontal directions E naught x E naught y matrix. That is along only x-axis. That's why E naught x e power I by x. Along y-axis is 0. For electric field vector along x-axis only we have taken. That's why I am written as A0. That is A0 or 10 we can write also. Where we have this set of the phase pi naught is equal pi x is equal to 0 for our convenience. Next we go to for vertically polarized light taken as y-axis. The electric field vector oscillations are only along the y-axis, and Jones vector then be written as E naught x E naught y, that is 0 along x-axis for y component, and E naught y e power I phi y. That's why we will written as 0 1, where we have set the phase as pi y is equal to 0. Next, for some angle, that arbitrary angle in between x and y, I am taken as alpha. We take for 45 degree like that. And the Jones vector is simply a line inclined that alpha is equal to tan inverse of E naught y divided by E naught x. And also we can return in terms of, since this one written as x square root of E naught x square plus E naught y square into cos alpha sin alpha matrix. Next, circularly polarized light. The Jones vector in this case where E naught x reads E naught y, that is E naught x is equal to E naught x e power I pi x, E naught y e power I pi y. And it has some angle that is a and e power I pi by 2. A common is 1 e power I pi by 2. Then the normalized form is these vectors represent circularly polarized, where E is left circularly polarized light or left-handed circular polarized. This mode is called left circularly polarized light. What is corresponds to for right circular polarized means replace pi by 2 as minus pi by 2. This one here I pi by 2 is there now. 1 minus I pi by 2 for right circularly polarized light. Next, for elliptically polarized light, where if E naught x is not equal to E naught y, for example, E naught x is equal to A and E naught y is equal to B and the zone vector can be written as 1 IB. This is a type of rotation is the left-handed, like this direction for clockwise direction, and 1 minus IB for the right-handed. We have arrow mark is like the same what I am showing the arrow mark for that left-handed or anti-clockwise direction. What determines the major and minor axis of the ellipse? Our question. That's why in general the zone vector for the arbitrary case, when del is equal to m phi, del is not equal to m phi, and del is also not equal to m plus of phi, then E naught is equal to E naught x, E naught by e power ideal. In terms of E naught x, I am taken as A, and E naught by e power ideal written as cos del plus I sin del, where tan 2 alpha is equal to, where A is the minor axis, B is the major axis, and okay, up to here for different state of polarizations we are discussed. Then next class we go to the